Okay, so we're going to work some problems in 5.1. First problem, got a function, negative x to the fourth plus 4x cubed minus 4x squared. I want to find all the zeros, determine the end behavior, and a lead coefficient. We'll start with the easiest part, the lead coefficient. I go and I look at each term. Which term has the largest degree? It's the first one, so that's going to tell me where the lead coefficient is. The lead coefficient is the number in front of the variable. That lead coefficient is equal to -1. Okay, so that's understood. -1 there. Now, in behavior. So we're talking about the graph here. Okay, what's happening as I go off to infinity or negative infinity? Okay, what's happening to the function f? Is it going up to infinity, down to negative infinity? All right, when I look at this lead term, negative x to the fourth, the negative number in front, okay, the negative number in front tells me that I'm going to be going down negative on the right-hand side, so down to negative infinity. Now, the exponent, 4, is even. That tells me that if I go down negative on the right side, I got to go down negative on the left side. It agrees. Okay, so the end behavior, this is how it's going to be written. It's going to say f of x goes to blank as x goes to infinity. So as x goes to infinity, where does f of x go? It goes to negative infinity. And same thing with the other one. F of x goes to blank as x goes to negative infinity. So as x goes to negative infinity, where does f of x go to? It goes to negative infinity. So that's how we type it into our Hawks. Awesome. All right, so let's see if we can't graph this. We need to find the zeros. How do I find the zeros? That's where f of x is equal to 0. So what is f of x? It's negative x to the fourth plus 4x cubed minus 4x squared. Okay, and I have that set equal to 0. So what am I going to do? Looks like there's an x squared in common between all of these. So let's factor it out. And the lead term's negative, so I'm going to factor out that negative. So negative x squared pulled out. What does that leave? That leaves a positive x squared plus what? 4x. Well, maybe it's not a plus. Maybe it's a minus because I'm dividing out the negative. Look, guys, for you that are having trouble following, I'm pulling out a negative x squared out of each of these, so it's like I'm dividing out negative x squared for each of them. A plus divided by a negative is a negative. That's where that's coming from, okay? And then here, I have a negative makes a positive, and the x squared's canceled, so I just have a 4 left. Okay, so now, this is factored. First part, negative x squared. But I need to factor this trinomial. Can it be factored? Well, let's see. I want something that multiplies to -4, or adds to -4 and multiplies to 4. 2 times 2 is 4, but 2 plus 2 is 4, so that doesn't work. But -2 times -2, that's 4, and then it adds to -4. So this, bingo, right there, that's going to be our answer. And since the coefficient in front of the squared term is 1, it's an easy factoring. It's going to be x minus 2, x minus 2. But I also have my negative x squared. And so I have this all equal to 0. And to solve, I set each piece equal to 0. Negative x squared equals 0. X minus 2 equal to 0. X minus 2 equal to 0. Well, guess what? Both of these are going to produce x equal to 2 as a root. Let's think about the multiplicity here. How many factors of x minus 2 do I have? I've got 2 of them, technically, right, guys? I mean, isn't this the same And that's x equal to 0, by the way. Isn't this the same as f of x equals negative x squared and then x minus 2 all squared, quantity squared, just like that? I think so. So my multiplicity for my x equal 2 root is even. It's a multiplicity equal to 2. My multiplicity for my x equal to 0 root is also, it's squared, so that's a multiplicity equal to 2. Remember, if my multiplicity is even, what do? I bounce, right? So I know that I'm going to start down at negative infinity. So I'm coming up, I'm coming up, I'm coming up. Now I don't cut through because it's not odd, but I flatten out because the degree is greater than 1, the multiplicity there. And then I come back down, and who cares how far we come down, as long as when we're coming back up to our next intercept, our next 0, we come here and we bounce again, and we ultimately go back down. Okay, so right and left-hand behavior, my end behavior, they're both going down to negative infinity. So it looks kind of like this here. So this is the graph that we're looking for. All right? So you might see a question, does it flatten out at the zeros? X equals 0 and x equal 2. And your answer is yes, and yes, if I can spell yes correctly, because the multiplicity at 0, it has a multiplicity of 2 greater than 1, and the multiplicity at 2, x equal 2, there's 2 copies of those, so it's got a multiplicity of 2. So yeah, it's greater than 1 also. So as we get really close to the root, the curve starts flattening out, it touches it, and then it goes back. And then again here, so that was at x equals 0, and then at x equal to 2. It's coming in, it flattens out, it touches it, and then it goes back. That's the idea of flattening out. Okay, there and there. All right, guys. Let's see. We can do one more. There might be a problem that you run into, maybe not. They give you a function and they say g of x equals x squared plus x minus 2. And they want you to plot the x-intercepts. They want you to sketch the graph. And identify where g of x is positive and negative. Okay, positive and negative. All right. So how are we going to do this? Okay, positive and negative. Well, you think about a graph. Okay, what type of shape is g of x? G of x is a parabola. If I think about the end behavior, all right, it's even degree. 2 is even degree. So that means they're either both sides are going up or both sides are going down. Okay, how do we know if it's going up or down? The number in front, the lead coefficient, is positive. When we're positive, we're smiling, just like this. So we know the end behavior is going up on both sides. Now we just got to figure out what's the damage in between. So how do we do that? Well, the critical point is where we go from being positive to negative, okay? So how do we know that critical point? That critical point is going to be when we cross at 0. Okay, so I set this equal to 0. 0 equals x squared plus x minus 2. Does this factor? Want something to multiply to negative 2 and add to 1. 2 times negative 1? Yeah, 2 minus 1 is 1, so good. That's good. So 2 and negative 1. So this is x plus 2 and x minus 1 equal to 0. Okay? If I set each of these equal to 0 and solve, I'm going to get zeros of x equals negative 2 and x equals positive 1. So let's plot these zeros. So at negative 2, okay, at negative 2, and at positive 1. Now, what do we know? We know the end behavior, positive infinity for both sides. So the graph is going to come down. Now, does it cross or does it bounce? Well, let's think about it. What is the multiplicity for this root? The multiplicity is 1. That's an odd multiplicity. Therefore, we cross through. Okay? And then what about for x equal to negative 1, or x minus 1 factor gives me this x equal to positive 1. Do we cross or do we bounce? We're going to cross through because the degree multiplicity is 1. Am I going to be doing any type of flattening out scenario? Is there going to be some type of flattening out? And the answer to that is no. Why is there no flattening out? Because the multiplicity for both of these roots is 1. It's not 2 or more. When the multiplicity is 1, then there's no flattening out occurring and it just crosses through. So just like this. Okay, so just like that. Now the question is, where is the function g of x? Where is it positive? Okay, it's positive here and here. So I can do green for positive. So where is that? On what interval? Remember, where is x? That's my x values. Okay, so where is it positive? G of x is greater than 0 for what values of x? For all x values that are from negative infinity up to what? Up to what? Negative 2, don't include it, because at negative 2 it actually equals 0. And then union, and where does it start back at? At 1, and we go out to infinity, just like that, okay? Now, negative, that's when g of x is less than 0. So where are we less than 0? From here to here. Where is the x value? So from negative 2 to 1. From negative 2 to 1. That's where g is less than 0. This is where g is greater than 0. It's positive. And here it's negative. Okay, guys, that concludes the video.